Right, so here's what we've been building up to. It's the factor theorem. It tells you that if a linear expression is a factor of a polynomial, then if you plug in the value that makes that linear expression 0, you get 0. And that makes full and complete sense if we think about it. When you see the examples, you'll see what I mean. So let's look at this one. You saw this earlier at the start. I asked you to work out g of minus 4, but just plugging minus 4 into the first bracket, you can see you get 0. So the whole thing's going to be 0, because it's going to be 0 times whatever this second one works out to be. So hopefully at least the right-hand direction of this implied sign is fairly obvious. Okay, the other direction perhaps not so much, but if you've got a factor like this, the x plus 4 in g of x, then g of minus 4 must be 0. And we could also have written g as x cubed plus 6x squared plus x minus 28. And if you plug minus 4 into that, you're still going to get 0. That's the whole point. So we're going to use this fact to factorise cubics. Here's one. Let's see what I mean. So, hello. Right. If this has a factor, then a linear one, then it will multiply by a quadratic, won't it, to give us the cubic back. So it will be x plus or minus something in here times by x squared, and then some x's, and then a number on the end. So it might feel a bit like, well, what numbers do I try? Well, focus on the 6 at the end. The 6 comes from these two numbers times together. So these two numbers must be factors of 6. Okay, plus or minus, positive or negative. So what are the options? 1, minus 1, 2, minus 2, 3, minus 3, 6, and minus 6. Feels like a lot of options, but we tend to find one fairly quickly. And you sort of start to build up an idea of what's the sensible thing to try. So let's start at the top and try a few of these, and we'll see what we get. So what's f of 1? So I'm calling this thing f of x for the sake of speed, so I can refer back to it. F of 1, you can work this out. You get 1 minus 4 plus 1 plus 6. Well, that's 4, so that's not equal to 0. So that tells me that x minus 1 is not a factor of f of x. Okay, let's try minus 1. If I plug that in, I get minus 1 cubed is minus 1, minus 4, minus 1, plus 6. So, oh, hello, that is 0. So I know that x plus 1, that's x minus minus 1, is a factor of f of x. Okay, that's what factor theorem tells me. Because I've got f of something being 0, that must mean that x minus that something is a factor. So I can stick minus 1 in my factorising up here, and I can figure out all the missing stuff. Minus 1 times something is plus 6, that's minus 6. And then if I look at the x squared term, I need minus 4x squared, but at the moment I've only got minus 1, so this must be minus 3x in there. And I can just check that works out with the x's. I get, where are my x's coming from? I get plus 3x's, and I get minus 6x's. And that doesn't work, does it? For pity's sake. Oh, no, I can see where I've gone wrong. What did I do wrong? Silly me. I said x plus 1 was a factor. Having a moment there. Right, so it's not x minus 1 that's a factor. It doesn't work because it didn't work, because it's not a factor. So let's go back and fix that. I'll go a bit more slowly over it. So, right, x plus 1 is a factor. X plus 1, brilliant. 1 times something is the 6, so that must be plus 6 on the end. Let's look at the x squared. So I've got plus an x squared, but I want minus 4x squared, so I must get minus 5x squared from the x times whatever's here, so that must be minus 5x. Okay, and I can check it, as I've been doing, by looking at the x's as well, because we haven't considered those yet. Where do I get x's from? I get minus 5x, and I get plus 6x, and that gives me my plus an x. So that works out beautifully, so I've factorised it. I could have kept trying, And we haven't fully factorised this quadratic. I could have kept trying these other numbers to find some other factors, but once you've got 1 for a cubic, you might as well just do what we've just done and factorise out the quadratic. And the final thing to do is to finish factorising if you can. Not every quadratic factorises, so that one might not, but it does. And hopefully you can all see that this quadratic factorises to x minus 3 and x minus 2. Okay, so that's that cubic I was given fully factorised. It might have felt a bit quick, but we're going to do a few more examples, so don't panic. Follow along with the first one or two, and then you can pause it, do the next next couple, and just check that you agree. Okay, so let's call this f of x for speed. Here's minus 6, so it's the same factors. It's 1, minus 1, 2, minus 2, 3, minus 3, 6, and minus 6. Those are the things I need to try. So let's just work through them systematically. F of 1 is 1 minus 6 plus 11 minus 6. Oh, how wonderfully lucky, that is 0. So what does that tell us? That tells us that x minus 1 is a factor. Okay, cool beans. So let's just factorise that then. So f of x must be x minus 1 times by some quadratic. So the x times x squared gives me the x cubed at the start. The minus 1 times something at the end gives me minus 6, so that's plus 6. Then thinking about the x squared terms, I've got minus an x squared, and I want minus 6x squared, so this must be minus 5x again. Oh, it's the same one we saw a minute ago. You see these same ones come up a lot because maths. So I've got one linear factor, and I'm just going to factorise the remaining quadratic, which is again x minus 3, x minus 2, sorry. So that's that one done and dusted. Right, next one. The number on the end is different. So factors of 10, 1, 2, 5, 10, and obviously all their positive and negative variations, so these ones as well. I don't really fancy plugging 10s in, so I'll start small. What's f of 1? F of 1 is 1 plus 2 minus 13 plus 10. Oh, hello. I found a factor at the start again. I didn't mean to do that so quickly. But that is 0. Therefore, once again, x minus 1 is a factor. I could keep going. I could try 2, and so on and so forth. I'm not gonna, because I've got one factor already. So I know that my cubic is equal to x minus 1 times some stuff. You can stop it and fill in the rest, but let's just see. X times x squared gives me the x cubed. Minus 1 times something gives me the plus 10, so that must be a minus 10. And then I just look at my x squareds. So minus an x squared, but I want plus 2x squared. So here I must get plus 3x squared, so that must be plus 3x. Okay, and I'll just check that with my x's. Where do I get my x's from? I get minus 10x and I get minus 3x. Yay, minus 13x. Fantastic, so that's what I was after. So that's correct, and I just need to finish the job and factorise the quadratic if I can, and in this case I can. X, well, it's 5 and 2, isn't it? And if I expand that, I'll get 5x and 2x, but I want positive 5x and minus 2x, so that's my final answer to that one. Okay, you might want to have a go at these two, pause it, have a go, and then check my answers. Cool, so call it f of x. Let's try f of 1 again. Always start with the simplest one. 1 minus 8 plus 6, well that's not equal to 0. So x minus 1 is not a factor. Okay, let's try minus 1. F of minus 1 is minus 1 plus 8. Oh, no, minus 8 plus 6. Oh no, it is plus 8. plus 8 plus 6. Yeah, that doesn't work either, does it? So that's not 0. Therefore, x plus 1 is not a factor. And now I'm slightly worried that I've made up a question that doesn't work. F of 2 is 8 minus 4 minus 16 plus 6, which is minus 6, so that's not 0. Therefore, x minus 2 is not a factor. F of minus 2 is minus 8 plus 4 plus 16 plus 6. Well, that's 18, so that's not equal to 0. So x plus 2 is not a factor. Oh dear. F of 3, well, I think the thing is, if none of those are, then it's not going to be possible. Let's just check these. F of 3, F of minus 3, F of 6. There's no point in me doing these because I've already established it's not going to work. But let's just see for kicks. That's 27 minus 9 minus 24 plus 6. Oh, that is 0. Oh. I'm losing my mind. Okay, that's 0. Cool. So what does that tell us? X minus 3 is a factor. Oh. I'll tell you what. Yeah, that's thrown me. Maybe I've missed something earlier on. You might have spotted a mistake I made in an earlier one. We'll see. This is what happens when you rush it before you eat breakfast. So I'm going to get rid of this stuff so I can factorise it. X minus 3 times by what? Times by x squared plus 2, right, minus 3x squared. I need some other x squareds because I want minus just a 1x squared for now, so that needs to be a plus 2x. Aha, yeah, okay, now I remember. Yeah, so this is me making up a question where the quadratic, this bit, doesn't factorise. Let's just check the x's. I get minus 6x. Oh yeah, I've got a sign error there, haven't I? This is why it's worth checking. That's a minus 2. Cool. And if I check that now, expanding it, I should get what I want. Yeah, plus 6, minus 2x, minus 6x, minus 8x, minus 3x squared, plus 2x squared. Yep, so minus an x squared. Yeah, cool. So I made this one up on purpose, and now I remember why. Because this quadratic doesn't factorise. So that is the answer. This is it completely factorised. Jobs are good. Okay. Handy. Right. Moving on to this next one. Don't be too phased by the 2. There'll be up to 3 brackets, and they can't all have a 2 in them. So one of them will have a 2 in them, but some won't. So we'll be all right. So we're going to try factors of 3. Let's call this f of x. So f of 1 is 2 minus 7 plus 2 plus 3. Oh, 0. So that's told me that x minus 1 is a factor. It's always worth checking the simple ones first. So f of x is x minus 1 times by, well, 2x squared to go in the front, minus 1 times something to give me the plus 3, so that's minus 3 here. And then if I look at my x squareds, I get minus 2x squared there, but I want minus 7x squared, so this must give me minus 5x squared, so minus 5x there. And then I'll check my x's. Where do the x's come from? Plus 5. Go. Get your pen out. Plus 5x minus 3x is plus 2x, so that all works out beautifully. Is the quadratic going to factorise? Well, you could check and you were working out the discriminant, but I can see it probably is in this case, so I'm just going to have a go. 2x and x. Right, 3 and 1, one of them negative, one of them positive. They need to times by the 2x and the x to give me minus 5x overall, so I think I need the 3 times the 2 to give me 6x minus 6x. and then plus another x. You can check by expanding that that works. Job is a good one. Have a go at these two and just check that you agree with me afterwards. Call this f of x. What's f of 1? Is 1 plus 2 minus 2 plus 3. Oh, well, that's 4, so that's not 0. So x minus 1 isn't as a factor. What's f of minus 1? I get minus 1 plus 2 plus 2 plus 3. Oh, it's not a factor either, is it? What about 3? F of 3 is 27 plus 18 minus 6 plus 3. Well, that's not 0. What about f of minus 3? Minus 27 plus 18 plus 6 plus 3. Ooh, that's 0. So that means that x plus 3 is a factor. So this is x plus 3 times some stuff, or times what? X times x squared is x cubed. 3 times 1 makes that. So 3x squared, I need minus an x squared, so that's minus an x there. And this is another example. If we check the x's, that will work. Minus 3x plus an x. Yeah, cool. This is another example then of the quadratic that doesn't factorise. So obviously none of the other numbers give me 0 when I plug them in because there's no other linear factors. So, but that's the answer. That's it. Factorised. Jobs are good. And this last one here. Oh, factors of 2. Not many of those, are there? Call this f. F of 1 is 3 minus 2 minus 3 plus 2, so that's 0. Oh, cool. X minus 1's a factor, so it's x minus 1, 3x squared, minus 2 in the end. That's minus 3x squared, but I want minus 2x squared, so I must get plus an x squared from that. Check, check, always check. Check it works for the x's as well. I get minus an x, and I get minus 2x. I've got minus 3x. Everyone's a winner. If you check by expanding that whole thing, it will work out. So finish factorising if you can. Does the quadratic factorise it? If it does, it will be 3x squared and x, and it'll be minus 2 and plus 1. Yeah, groovy. There you go. So I don't know why that's labelled as question 4. Confusing. Anyway, that's how we use factor theorem to factorise cubics, and I want you to practice that with the other questions if you get well for homework. Okay, so hopefully you worked through the videos and had some success with some of those, and yeah, hit me on an email if you've got any questions. Thanks.